Hello everyone, welcome to the online class. I Vikas Kacha Patel from Param Guru Pathshala English Medium School, Sarsa. Standard 12 Science, Subject Mathematics, Unit number 1, Relation and Function. Today I will start exercise 1.3. Question number 1. Let function f from set 134 to set 125 and function g from set 125 to set 13 be given by f of x is equal to order pair 1 2 comma 3 5 comma 4 1 and function g is equal to order pair 1 3 2 3 and 5 1. So write down g composition f. Okay, so first of all here set, suppose a is equal to 1 3 4 and b is equal to 1 2 5. Okay, here function f from a to b, here function value f of x is equal to order pair 1 2 3 5 4 1. So first of all here f of 1 is equal to 2, f of 3 is equal to 5 and f of 4 is equal to 1. Okay, similarly here g from set 1 to 5 to set 1 3, here g of x is equal to order pair 1 3 2 3 and 5 1. Okay, so therefore g of 1 is equal to 3, g of 2 is equal to 3 and g of 5 is equal to 1. Okay, so now for every x, okay, so g composition of f from 1 3 4 to set 1 3. Okay, because here rf subset domain of g, rf subset domain of g. Okay, here 1 2 5 and domain of g 1 2 5, that means range codomain of f is equal to domain of g. So therefore g composition of f from map 1 3 4 to 1 3. Okay, so g composition of f of 1 is equal to g of f of 1, but here f of 1 is equal to 2, so substitute f of 1 is equal to 2, so that is equal to g of 2. Okay, but here g of 2 is equal to 3, so g of 2 is equal to 3, that means g composition of f of 1 is equal to 3. Okay, second, g composition of f of 3 is equal to g of f of 3. That means here f of 3 is equal to 5, that is equal to g of 5 and g of 5 is equal to 1. Okay, g of 5 is equal to 1, so therefore g composition of f of 3 is equal to 1. Okay, next, g composition of f of 4 is equal to g of f of 4. Here f of 4 is equal to 1, so g of 1 is equal to g of 1 is equal to 3. Okay, so therefore g composition of f is equal to order pair 1 3 3 1 and 4 3. Okay, next question number 3. Find g composition f and f composition g if first f of x is equal to modulo x and g of x is equal to modulo 5x minus 2. Okay, here two function f and g map from r to r. Okay, so f from r to r and g from r to r, so therefore g composition of f from r to r, so for every x belongs to r, so g composition of f of x is equal to g of x, but here f of x equal to modulo x, so substitute f of x is equal to modulo x, so g of f of x is equal to g of modulo x. Okay, but here g of x is equal to modulo 5x minus 2, so then substitute x is equal to modulo x. Okay, so is equal to modulo of 5 modulo x minus 2. Okay, similarly f composition g, the f composition g of x is equal to f of g of x. Okay, here g of x equal to 5x minus 2, substitute. Okay, so here f of modulo of 5x minus 2. Okay, but here f of x equal to modulo x, so substitute x is equal to modulo 5x minus 2. Okay, so here modulo, again modulo 5x minus 2. Okay, here 2 times modulo, so then modulo 5x minus 2, but here 5x minus 2 is equal to g of x, so is equal to g of x. Okay, next question number 3, find g composition f and f composition g if second number f of x is equal to 8x cube and g of x is equal to x raised to 1 by 3. Okay, here two function f from R to R, f of x equal to 8x cube and g from R to R, g of x equal to x raised to 1 by 3. So therefore g composition of f from R to R, so g composition of f of x is equal to g of f of x, but here f of x equal to 8x cube, substitute, so is equal to g of 8x cube. Okay, but here g of x equal to x raised to 1 by 3, to take x equal to 8x cube, so then 8x cube raised to 1 by 3. Okay, so here 8x cube that means 2x whole cube, to 2x whole cube and raised to 1 by 3, so cube and 1 by 3 cancel out, so then 2x. Okay, here 2x. Okay, for every x, for f composition g of x is equal to f of g of x. Okay, here g of x, so g of x is equal to x raised to 1 by 3, so substitute g of x equal to x raised to 1 by 3, so is equal to f of x raised to 1 by 3. Okay, here f of x equal to 8x cube, f of x is equal to 8x cube, so substitute x is equal to x raised to 1 by 3, so is equal to 8 x raised to 1 by 3 raised to 1 by 3, so 3 cancel out, means 8x. Okay, means 8x. Now question number 4, if f of x is equal to 4x plus 3 upon 6x minus 4, where x not equal to 2 by 3, so that f composition of f of x is equal to x for every x not equal to 2 by 3, what is the inverse of f? Here first of all function f of x equal to 4x plus 3 upon 6x minus 4, where x not equal to 2 by 3. Why x not equal to 2 by 3? Because here 6x minus 4, so substitute x equal to 2 by 3, x equal to 2 by 3, so 6 2 by 3. Okay, so 6 upon 3, so 2 into 2 4, 4 minus 4 0. So okay, so f of x something upon 0 means undefined function. Okay, so therefore x not equal to 2 by 3. Okay, so first of all here f of x is equal to x, so now f of x is equal to f of x. Okay, but here f of x equal to 4x plus 3 divided by 6x minus 4. Okay, so substituted again x equal to 4x plus 3 upon 6x minus 4, so is equal to 4 into 4x plus 3 upon 6x minus 4 plus 3 divided by 6 into 4x plus 3 upon 6x minus 4 upon 4. Okay, here 6x minus 4 upon 6x minus 4 cancel out. Okay, so both side LCM, so 4 into 4 16x, so 4 into 4 16x plus 12. Okay, 16x plus 12 and 6 3 18x and plus minus 4 3 9. 12. Okay. Similarly, 6 4 ja 20x, 6 3 ja 18 plus 18 plus minus minus 6 4 ja minus 24x and minus minus plus, the 4 4 ja 16. Okay. So first of all here plus 12 minus 12 cancel out, so there plus 12 minus 12 cancel out, and 24x minus 24x cancel out. So then 16x plus 18x, so 16 plus 18 34x upon 18 plus 16, so 18 plus 16 again 34, so upon 34, to 34x upon 34, so is equal to x. So therefore f composition of f of x is equal to x. X means identity function. Okay, then is identity function. Okay, so hence the given function f is invertible and the inverse of f is itself. Okay, why itself? The f composition g is equal to identity function and g composition of f is equal to identity function. So therefore f and f is inverse of g. Okay, so therefore f is inverse of f is itself. Okay, so inverse of f inverse x equal to 4x plus 3 upon 6x minus 4. Okay, next question number 5. State with the reason whether following function have inverse. First, f from set 1 2 3 4 to set 10. Okay, f is equal to order pair 110, 210, 310 and 410. The first question, okay, here f from 1 2 3 4 to 10. So first of all here domain of f is equal to 1 2 3 4 and codomain is equal to 10. Okay, so now first of all here inverse function. So what is inverse function? F is inverse function. So f is 1 1 and 1 2, so then f inverse exists. So first of all check 1 1 function. Okay, so here for every x1 and x2 belongs to set 1 2 3 4. So first of all here f of 1 is equal to 10 and f of 2, so f of 2 is equal to again 10. So here f of 1 is equal to f of 2 but 1 not equal to 2. Okay, so therefore f is not 1 1 function because here image of 1 is 10 and image of 2 is 10, means same image. So therefore f is not 1 1 function. Okay, but here f is onto function because here range of f is equal to only 10 and 10 is equal to codomain. So therefore f is onto function, but here f is not 1 1 function. So therefore f does not exist. Okay, f is inverse does not exist. Second, g from set 5 6 7 8 and set 1 2 3 4. Okay, means here domain of g 5 6 7 8 and codomain of g 1 2 3 4. We define g is equal to order pair 5 4 6 3 7 4 and 8 2. Here first of all check 1 1 function and onto function. So here f of 5 is equal to 4 and f of 7, so f of 7 is equal to 4. That means image of 5 is 4 and image of 7 is 4. So that means f of 5 is equal to f of 7 but 5 not equal to 7. So therefore f is not 1 1 function. So that means 1 1 not f is not 1 1 function. So therefore f inverse does not exist. F inverse does not exist. But here g range of function g is equal to 4 3 2. Okay, so range of g not equal to codomain of G, so therefore G is therefore G is not onto function. Okay, so therefore G is not 1 and onto function, so therefore G does not G inverse does not exist. Okay, so therefore G inverse does not exist. Next, third number. Here function h from set 2 3 4 5 to set 7 9 11 13. That means here domain of h is equal to 2 3 4 5 and codomain 7 9 11 13. Here h of x is equal to order pair 2 7 3 9 4 11 and 5 13. So for every x belongs to domain, here domain is equal to 2 3 4 5. Okay, so h of 2, so h of 2 is equal to 7, h of 3 is equal to 9, h of 4 is equal to 11 and h of 5 is equal to 13. So that means image of 2 is 7, image of 3 is 9, image of 4 is 11 and image of 5 is 13. So that means different distinct number, to then value different value, so therefore f is 1 function. Okay, f is 1 function. And next, range of function h, range of function h. So here range of function h is equal to 7 9 11 and 13. H range of function h is equal to 7 9 11 13, but here set 7 9 11 30 is equal to codomain of h, so therefore range of h is equal to codomain of h, so therefore h is onto function. So there here h is 1 and onto function, so therefore h inverse exists, so therefore h inverse exists. Okay, now question number 6. Show that f from close interval minus 1 to 1 to r given by f of x is equal to x upon x plus 2 is 1 function. Find the inverse of the function f from close interval minus 1 to 1 to range of function f. Okay, here first of all check 1 function. So here f from close interval minus 1 to 1 to r is given as function f of x is equal to x plus 2. So for every x and y belongs to minus 1 to close interval minus 1 to 1, so let f of x equal to f of y. Here f of x equal to x plus 2 and f of y, so f of y is equal to y upon y plus 2, so therefore x upon x plus 2 is equal to y upon y plus 2. So therefore next cross multiplication, so cross multiplication x into y plus 2 is equal to y into x plus 2, so therefore x into y plus 2x is equal to x into y plus 2y. Okay, so both side xy same value, so they can cancel out, the xy cancel out, so therefore 2x is equal to 2y. Okay, so both side 2 cancel out, so therefore x is equal to y, so therefore f is 1 function. Okay, so next check onto function. So for every y belongs to range of f, for every y belongs to range of f, there exists x is equal to 2y upon 1 minus y in minus 1 to 1 such that f of x is equal to y. Why f of x is equal to y? Here substitute x equal to 2y upon 1 minus y in f of x. So substitute here f of x is equal to 2y upon 1 minus y upon 2y upon 1 minus y plus 2. Okay, so here 1 minus upon 1 minus y upon 1 minus y cancel out, so that means f of x is equal to y. Okay, so it is clear that f from minus 1 to 1 to range of f is onto function. Okay, so therefore f from close interval minus 1 to 1 to range of f is 1 1 and 1 2 and the inverse of the function f. Okay, our next find the inverse of function f from minus 1 to 1, okay, to range of function f. So suppose here g from function g and g of x is equal to 2y upon 1 minus y. The first find f composition g and g composition f. So the first find the value of f composition g is equal to identity function and g composition of f, the identity function. So therefore f composition of g is equal to g composition of f is equal to identity function. So therefore f inverse exists. Okay, and here f inverse x is equal to 2x upon 1 upon x. Okay, now question number 7. Consider f from R to R given by f of x equal to 4x plus 3 so that f is invertible. Find the inverse of f. Okay, here so that f is invertible and find the inverse of f. The first find inverse of f. The inverse of f find the first of all check 1 1 function and on 2 function. So let for every xy belongs to R, here f from R to R, so set R is means real number set. Okay, so for every xy belongs to R, so f of x equal to f of y. Okay, so f of x equal to 4x plus 3 and f of y is equal to 4y plus 3. So therefore 4x plus 3 is equal to 4y plus 3. Okay, both sides 3 cancel out. So therefore 4x is equal to 4y. Okay, so 4 cancel out. So therefore x is equal to y. X equal to y. So therefore f is 1 1 function. Okay, f is 1 1 function. For every y belongs to R, so there exists x is equal to y minus 3 upon 4 in R such that f of x is equal to y. Why f of x equal to y? So substitute x is equal to y minus 3 upon 4 in f of x. Okay, so f of x equal to 4, here substituted value of x. So x is equal to y minus 3 upon 4. So that is f of x is equal to 4 into y minus 3 upon 4 plus 3. Here 4 cancel out. So that is equal to y minus 3 plus 3. Minus 3 plus 3 cancel out. So is equal to y. But here y belongs to R. So y belongs to R. So therefore f is onto function. Okay, so here therefore f is 1 1 and onto function. So therefore f inverse exists. Okay, f inverse exists. And so now let g function. Okay, g from R to R defined as g of x is equal to x minus 3 upon 4. So again find f composition g and g composition f. So we get identity function. So f composition g of x is equal to identity function and g composition of f is identity function. So therefore f is invertible function. F is invertible function. To contact our school, Param Guru Pathshala English Medium School. Thank you very much. Sat Keval Sai.